This clip is an example of infraslow waves as they develop in the jhanas. The basic screen setup is the same as for clip 1, and in this case there are 31 electrodes. The clip begins with the meditator about to develop the first rupa jhana, and then the second and higher jhanas. In this case, these labels are not cues given to the meditator to change stages. They were added by me during the recording as a rough guide to compare to the subject's recollections directly after the recording. This meditator is experienced and is following his own regular practice without cues. Slow waves develop quite quickly and are already deceptively strong. The intensity scale is 300 microvolts per centimetre, so these traces are already almost 200 microvolts peak to peak, which is about 10 times the normal resting state non-meditating level. I'm now going to speed up the replay to show how the slow waves develop. From this point on, the slow waves develop steadily, until from here some rather dramatic changes begin to develop. What we are looking at here is a very large inhibition of intensity which corresponds to the subject's recollection of experiencing a step change to deeper concentration following a resolution to move towards the second rupa jhana. If I change the scale and offset, we can see this more clearly. The inhibition is focused strongly at the crown of the head electrode CZ, and just posterior to that at electrode CPZ, just edging into the parietal cortex. If I select electrode CZ, we can see this more clearly. Since the scale is 300 microvolts per centimetre, the inhibition amounts to more than 2,500 microvolts, which is extremely high by neuroscience standards. Now looking in more detail, this left-hand map shows the start point of the yellow highlighted segment before the major inhibition begins, at which point the brain's activity is steady and at an average intensity, neither enhanced nor inhibited. Moving ahead in the timeline, the right-hand window shows the changes in intensity across the head with alternating peaks and troughs. And here is an example of the richness of the detail in these recordings. At this point the activity at the vertex is strongly suppressed, while around it there are hot spots of excitation, red, which appear to be counterparts to the central inhibition. As we continue to follow the strengthening peaks, we can see activity at the vertex gradually shift from inhibition, pale blue colour, to increasing excitation, first red such as here, then to very strong yellow excitation such as here. For this whole yellow highlighted segment, the spectra or intensity distribution across the head look like this. The peak at the crown of the head is made up entirely of very intense slow waves. The software has no choice but to place it in the delta plot, which is usually 1 to 4 cycles per second, but these slow waves in jhana meditation are actually much slower than in deep sleep or even coma, hence referred to as infraslow waves in the book. The other frequency bands of sensory consciousness show no discernible activity compared to the intense infraslow activity at the crown of the head. We now look at how these infraslow waves develop further and slower in the higher jhanas. The replay now speeds up to show how the slow waves develop. At this point, the slow waves are settled into a fairly steady rhythm, but it is difficult to work out the periodicity since the peaks are not evenly spread. And it's likely there are at least two different rhythms contributing. To check this, the underlying cortical sources need to be calculated, which takes time, so I've done the calculation in advance, and here is the result. This shows 31 independent sources contributing to the overall brain's activity, each marked as a percent of the total activity. If I scroll down from the strongest sources at the top to the weaker ones lower down, we can see the most dominant activity, as expected, is at the crown of the head, though at this stage not completely dominant since other areas of the brain still show weaker activity. The first strongest component, 31.3%, indicates two possible sub-peaks at 0.02 Hz, 50 seconds periodicity, and 0.05 Hz, 20 seconds periodicity, not yet fully distinguished from each other. The next strongest component, 12.6%, shows the broader distribution from 0.02 to 0.12 Hz, where 0.12 Hz or 8 seconds periodicity was the figure mentioned in the book as an average across several different meditators. And the third strongest source, 10.7%, shows the sharp peak at 0.02 Hz, 50 seconds periodicity, the same as one of the split peaks for the top component. These are all unusually slow rhythms. We now continue to follow the progression as the level of jhana deepens. And we gradually begin to see evidence of an even slower rhythm developing. This slower rhythm has come to a peak here, and if I select the crown of head electrode, we can see the intensity of this peak at 480 seconds. Given the scale 300 volts per centimetre, this peak is approaching 3000 microvolts peak to trough, absolutely unprecedented in neuroscience. The 3D spectra for this whole selection, calculated as before, look like this, where again we can see the vertex source dominant, with all other bands normally seen in sensory consciousness effectively silent. Again there looks to be more than one rhythm here, and the underlying cortical sources calculated in advance as before are here. This time if I scroll through the sources you can see the crown of head source is now pretty well totally dominant. In fact, table 4 in the book shows the dominance reaches 99% for parts of this recording. The strongest source at the top, 43.3%, shows a main peak at 0.02 to 0.03 Hz, which is 33 to 50 seconds periodicity, and a weaker peak at 0.08 Hz, 12.5 seconds periodicity. The second strongest component, 8.4%, also shows peaks at 0.02 to 0.03 Hz, while the third strongest, contributing 7.6%, is a single sharp peak at 0.02 Hz. This whole progression to rhythms as slow as 50 seconds periodicity was interpreted in the book as evidence of a progression from the second to the third and fourth Rupa jhanas. This point in the recording is now 20 minutes after beginning meditation, and the recording continues for another more than 15 minutes, with the meditator able to maintain these extremely slow waves for that duration. I must add here that we've been extremely fortunate to have a few meditators who can sustain such activity for long periods, to be able to see such slow rhythms, extremely rare in neuroscience but also very difficult to record. They require very stable equipment able to work with such slow frequencies and long enough recordings. In fact, as far as I'm aware, there have been no other published examples even approaching rhythms such as these. Figure 44 in the book, which is figure 44A in these web pages, gives a different view of the brain's activity at this point. The crown of head activity is composed entirely of infraslow waves focused at the crown of head, directly above the brainstem. It's important to remember that as these extremely slow rhythms at the crown of head become overwhelmingly dominant, that at the same time, all the slower sensory consciousness rhythms across the brain become progressively more silent, confirming for the first time that it is possible for ordinary human beings to temporarily disengage from their habitual mode of consciousness, which we've all lived in for most of our lives from birth, to this quite different form of consciousness, jhana consciousness. Very slow rhythms such as these strongly suggest there are visceral and metabolic factors in play during the experiences of jhana, involving the body as much as the brain.